It's 12 o'clock. Welcome to this week's Iowa Learning Farms webinar. I'm Matt Helmers at Iowa State University, director of the Iowa Nutrient Research Center and a faculty member with the Iowa Learning Farms group. Really fortunate to be able to host the webinar this week, and definitely an important topic. So we are fortunate to have join us today Dr. Mike Castellano, that's a professor of agronomy and the William T. Frankenberger Professor of Soil Science here at Iowa State University. He's going to talk to us about improving on-farm nitrogen use efficiency through the Iowa Nitrogen Initiative. So with that, I will turn it over to Mike. One logistical item, as always, feel free to type questions into the chat box, and we will get those to Dr. Castellano at the end of his talk. With that, the virtual floor is all yours, Mike.
Great, thanks, Matt. Appreciate it. I'm excited to talk today about the new Iowa Nitrogen Initiative. So really, our goal through this nitrogen initiative is to bring Iowans the best nitrogen science in the world for the benefit of productivity, profitability, and of course, environmental performance. We're doing that through a unique public-private partnership where we're conducting literally hundreds of scientifically robust experiments on farms every year throughout the state. The data we're generating through those experiments are going to allow us at Iowa State University to use the latest advances in computer science, process modeling, and machine learning to really bring the best nitrogen science and nitrogen fertilizer recommendations to Iowa farmers. This is really going to allow us to maintain and really increase our leadership as the most efficient corn and soybean farmers in the world. And this will, as I'll get to this a little bit, this will be key, I think, as environmental markets come online, as we've seen through things like carbon markets and nutrient trading markets as well. So we really hope this project serves a diversity of needs for folks in the state, on farms and off farms as well. So why now, right? Why the Iowa Nitrogen Initiative in 2022 and beyond? So optimum nitrogen rates are variable and changing. This figure is from over 100 site years. In other words, over 100 experiments in Iowa and Illinois. On the y-axis there, we have the economic optimum nitrogen rate. So that's the rate you want to apply if you want to maximize your profitability. And then the year of the study on the x-axis. You can see in green, corn following corn, and in yellow, corn following soybeans. The optimum rates are going up for both systems, but that's really not what you want to focus on here, because that's not the most important thing in this figure. What the most important piece of data in this figure is the extreme variability within years, right? So look at that. So for example, in 2004 here, all the way from close to zero to nearly 300 pounds per acre. And you can see that top line there just indicating that basically sometimes the optimum rate is off the chart. Why are they increasing? There's a variety of reasons. The number one reason is that yields are increasing. We're pulling more nitrogen off the field. But the climate also is becoming wetter. That's another reason. And a third reason is that as yields are increasing, we're producing more residue. The more crop residue on the ground, the more nitrogen that gets immobilized in that residue as microbes decompose it. And as a result, we need more fertilizer. Now, that's not necessarily a bad thing, as I'll show you, but the goal of this project is to really create system and year-specific recommendations so that we're not just managing for the average, right? So really, what is the nitrogen fertilizer rate, and what's the status quo with nitrogen fertilizer management? So I want you to think about this figure here. I know there's a lot of folks on that'll hopefully get some CCA credits. So think about this figure here with the open panel, right? And the figure on the lower left. So on the figure on the lower left, We have nitrogen rate on the x-axis, yield on the y-axis down here. This would represent an experiment from one field, 1 year. And so we put out different nitrogen rates, we measure the yield response, and then you get the optimum nitrogen rate, right? So where yield really begins to plateau and it's no longer nitrogen limited. The economic optimum nitrogen rate is always 97 to 99% of the nitrogen unlimited yield, right? So in other words, of essentially of yield potential. So if we take 150 of these experiments and we plot this optimum, the green circle here, on this figure, what's it going to look like? So optimum nitrogen input from all these experiments on the x-axis, and then the grain yield that you get at that optimum nitrogen input on the y-axis. Is it positive? Is it flat? Is it variable? What do you think? And so you can see these data in the corn nitrogen rate calculator online, linked on the lower right there. These data come directly from that corn nitrogen rate calculator. And what you'll find is that there is no relationship whatsoever. So grain yield is not necessarily a great predictor, although at very high levels it certainly is. And you can see a little slight positive slope there. That's why I mentioned earlier that in fact, increasing grain yields are increasing the nitrogen fertilizer demand. But overall, again, the story is the variability, right? The variability is the story there. And so what's our best recommendation? The average, right? That's the current land-grant university recommendation across 7 states that account for more than 60% of the corn production in the United States, the average. And so it's not just the average. For example, we have 4 recommended fertilizer rates in Iowa, 1 for corn following corn in Southeast Iowa, 1 for corn following corn in the rest of the state, and again, 1 for corn following soybeans in Southeastern Iowa, 1 for corn following corn in the rest of the state. But there is no specific recommendation for things like weather years, which we know has an enormous effect on the optimum nitrogen rate. Things like soil type within those regions, management systems. Are we managing the residue? Are we managing the drainage? Are we using one type of genetics or another? What's the planting date? Decisions like that. All these decisions, of course, have effects on the optimum nitrogen rate, some of them predictable, yet they're not accounted for in this model. And as you'll see, this creates a lot of opportunity to improve nitrogen fertilizer recommendations. It also creates a lot of opportunity to reduce environmental nitrogen losses of fertilizer and increase the profitability and productivity of Iowa farms. So nitrogen is necessary for productivity, profitability, and environmental performance, as I've mentioned several times now. And it's really the optimum rate that's important. So I want to show you a couple figures through the next 2 slides and focus on the x-axis here. This is not the amount of nitrogen fertilizer. This is the amount of nitrogen fertilizer relative to the optimum for the system. So insufficient, optimum, and excessive. And notice that here we're looking at the change in soil organic carbon. If we under-fertilize, we lose soil organic carbon because we're mining the nutrients from the soil. If we over-fertilize, we're losing soil organic carbon as well, or we're not capturing all the carbon we could because the plant gets lazy and it doesn't grow as many roots. And we've shown these through students and postdocs in our groups have shown these through several papers there on the lower right. Also, notice again on the x-axis, we're still sticking with nitrogen fertilizer relative to sufficiency for the crop. Nitrogen losses to N2O and nitrate, do they increase a little bit from insufficient to optimum? Yes, they do. But the increase is very little relative to the increase once you go beyond that optimum nitrogen rate. Why? Well, because here, if you increase the fertilizer, where does most of it go? It goes into that crop sink, right? That crop needs more fertilizer. It's going to take it up very efficiently. It's once you get beyond it that the nitrogen fertilizer losses to the environment really go up because there's no longer a crop sink for that nitrogen anymore. And that's why fertilizing for the optimum nitrogen rate is really important. And if we were to scale this on a per bushel basis, we'd find that nitrogen losses per bushel of corn are actually minimized at that optimum as a result of the figure here. So if we think about that relative to those data that I showed you earlier, the outcomes of all these nitrogen fertilizer rate trials, what would be the consequence instead of managing for the average and managing for the site-specific optimum? Well, right now, when we recommend the average, we have a lot of folks that could have gotten away with a lot less fertilizer over applying if they're following the land grant recommendation. On the other hand, of course, there are some folks, about 30 to 40% of the trials in the database, that are under applying if they're applying that average. And because of that relationship I showed you, though, bringing these folks who are over applying when they're applying the land grant recommendation down to where they should be will save much more nitrogen losses or avoid much more nitrogen losses than bringing those folks that are under applying up to the optimum, right? Because bringing the folks that are under applying will be moving them along this side of the curve. On the left here towards the optimum, will losses increase? Slightly, yes. But bringing down those folks that are over applying when they're applying the land grant recommendation down to the optimum will create major savings in terms of environmental nitrogen losses. So how are we doing this? I mentioned we're doing it through a public-private partnership with industry and farmers. This is unique as far as we know. It really allows us to conduct hundreds of trials on farm every year. And I would encourage you to reach out to me if you're a farmer and you'd like to get involved with the trials, or you work with farmers and you think some of the farmers that you work with would be interested in getting involved in some of these trials. So we are working with a couple of private companies. Premier Crop Systems, based in Des Moines, Iowa, is one of the companies. And what we do with Premier Crop Systems is look at a field's yield history, and we set up replicated, scientifically robust nitrogen fertilizer rate experiments in high yielding portions of the field. You can see that on the upper portion of the field here, and low yielding portions of the field. So typically we have 2 replicated plot trials in every experiment. The farmer gets a prescription for fertilizer application. It gets applied without any hassle as the applicator is going through. It adjusts based on the prescription. Really no hassle for farmers participating in the trials at all. I want to emphasize that. And what we get, what's really nice about this is we get the as applied nitrogen fertilizer data, and then we can marry that with the yield data at the end of the season. And we are really confident about the data that we get out of these as a result. In addition to conducting the trial, we're also conducting extensive soil and plant sampling in these trials as well. So each one of these colors I should have mentioned represents a different nitrogen fertilizer rate, right? And so, and that's what we're seeing the result of there on the right. And this is what one of those trials looks like in the field from above. You can see the low and the 0 nitrogen fertilizer rate plots. You can't see the well-fertilized ones as easily because they're nice and dark green. But these data are absolutely required to make those site and year-specific fertilizer rates through these advances in process modeling, computer science, data analytics that have been achieved in the past few years. And really, Iowa State in particular, the College of Engineering is an international leader on. So 3 tools for Iowa: a benchmarking tool, modeling forecasting tool, and a modeling hindcasting tool. And I'll just explain these quickly for everybody. So the benchmarking tool would allow farmers to sort through those data I showed you earlier to identify what's the optimum nitrogen fertilizer rate for my system, what's the variability, what did it look like, what would it look like in this type of system versus that type of system, this year versus that year. what's the uncertainty there? This tool will be completely transparent. So unlike the current system for nitrogen recommendations, all the stakeholders in the state, anybody who gets on the web, will be able to see the outcomes of these nitrogen fertilizer rate trials. They'll be anonymized, of course, at a county and soil type basis, but people will be able to see within a county, within a soil type, as we get enough trials, what the yield response to those nitrogen fertilizer rates look like on a particular field in a particular year, allowing people to see what really leading farmers are capable of. Benchmarking tool through that transparency and data access will also, I think, push folks in the right direction in terms of fertilizer management. You know, I'd like to tell this story about roadside hotels. You know, so if you've ever traveled for work and you stay in a hotel, you know, you pick whatever one you want. On the bathroom sink, there's a little sign that says if you reuse your towels to the next day, you'll save X gallons of water and help the environment. It turns out nobody does that, right? But if you take that sign and you replace it with a sign that says 50% of the people who stay in this hotel reuse their towels every day, the adoption rate goes above 50%. So we think this tool will have a major impact on really driving efficiency in the state. Modeling forecasting. So the forecasting tool will really describe the uncertainty in nitrogen, the optimum nitrogen fertilizer rate as the season progresses. And as the season progresses, of course, you'll see the uncertainty reduce in optimum nitrogen fertilizer rates. And that really highlights the importance of practices like side dressing nitrogen fertilizer, moving from the fall to the spring, things like that, that really allow a better understanding of what the optimum rate is and managing for that optimum rate. And then modeling hindcasting. So hindcasting is all about, this is what I did. If I had done this, what would have happened? Seeing those scenarios play out. And so really, it's all about probability-based decision-making. As long as we have weather, there's always going to be uncertainty in what the optimum nitrogen rate is, but reducing that uncertainty and showing the probability-based outcomes is a major goal of this project. So moving from an average to a probability-based recommendation. So a little progress we've made on this project. We've done some sensitivity analyses to improve the efficiency of our on-farm experiments. So we don't have to ask farmers to put in a bunch of zero nitrogen rates on their cornfields. Fall nitrogen, encouragement for some soil testing in extreme weather years, and identifying management systems that consistently reduce the amount and year-to-year variability of nitrogen fertilizer rates, because that's what it's really all about, right? We want to reduce the amount of nitrogen fertilizer required per bushel of grain and the year-to-year variability, which will improve productivity, profitability, and environmental performance. So this is a little work done by a PhD student of Sotirios Archantoulis, who co-leads this project with me, Mitch Baum. And so Mitch looked at nitrogen rates on the left here and the sensitivity of predicting that optimum, identifying that optimum nitrogen fertilizer rate if we're uncertain about the yield at 0, 45, 90, up to 270. And so what's this showing on the bottom is if we have some error in the low nitrogen rates in the 0s and the 45s, if we're off by 10%, it really makes almost no difference in the modeled optimum nitrogen fertilizer rate. But if we are off at the rates that are around the optimum, 180 or 135, it makes a big difference. And so this has really allowed us to better plan these experiments, allocate our resources more efficiently. So we're a more efficient process, and we have a better relationship working with farmers as a result. Some other things, thinking about the controls on yield response to N. So EONR equals the economic optimum nitrogen rate, YEONR, the yield at the economic optimum nitrogen rate, and Y0, the yield at 0 nitrogen. And you can see what it's sensitive to. Residual nitrogen, which I'll come to in the next slide, come back to. Of course, very sensitive to the weather. Genetics, sensitive to management, which includes a bunch of things. This is a rough analysis, but this is where we're going, right? To identify these things and really identify systems that allow us to reduce the total amount and year-to-year variability in optimum nitrogen rate. This is a letter Lance Lillibridge, the president of the Iowa Corn Growers, and I wrote in the Des Moines Register based on some model results. So Soterios modeled the residual soil nitrate in September 2021, really after corn had matured and stopped taking up nitrogen. And as you might imagine, with the dry conditions last year, we had quite a bit of residual nitrogen hanging around in the soil. And so taking these results, we got together with the corn growers and encouraged farmers to make some fall season soil nitrate measurements to see what's left before we begin putting down fall nitrogen fertilizer. And interestingly, we had several farmers come back to us after they did that. And if anything, our measurements were a little bit conservative. And of course, these model outputs are all based on measurements throughout the state that are coupled with process models, just like weather forecasts that use mathematical representations of biological processes to predict how much nitrogen is there, what the crop yield is, things like that. And you can see how much higher this was in September 2021, the percent deviation from the 5-year average. And it was over a third higher. Drainage is another management system that we know to affect the optimum nitrogen rate. So this is just a conceptual figure of drainage. On the left, we have a poorly drained system. On the right, a well-drained system. So drainage reduces soil organic matter on one hand, but it also increases the rates of nitrogen cycling. It reduces the amount of denitrification losses to nitrous oxide and dinitrogen. And as a result, and it increases the rooting depth and volume that the corn roots can explore. As a result, it consistently reduces the optimum nitrogen fertilizer rate, as well as increasing the grain yield, as farmers well known. There's a link there at the bottom of the slide. Coincidentally, yesterday I gave a webinar really just dedicated to this concept, showing a lot of empirical data describing those processes that I just went through. I also want to highlight Bill Crumpton a couple of weeks ago, or maybe a month ago now, on the Iowa Learning Farms webinar, gave a great presentation talking about how increasing drainage and coupling that with wetlands at the bottom of watersheds really allows us to improve drainage without sacrificing water quality at all. Excellent presentation by Bill. I'd encourage the audience to go back and take a look at that one if you didn't have the chance. And really here is just kind of an idealized concept of the system. But again, we are trying to come to identify practices that consistently reduce the amount and variability in that nitrogen fertilizer rate. And then finally, markets. I mentioned this at the beginning. So without a basis to demonstrate what rational nitrogen fertilizer rates are for specific operations in specific years, farmers aren't going to be able to participate to the best of our ability on new and emerging carbon and nutrient trading markets. When we can identify what rational nitrogen fertilizer rates were, where we are relative to those, it really allows us to be the leaders in gaining the profits from those markets, profits that other folks in other states won't be able to reap if they don't have data like that we're generating through this project. So just some timelines: goal of 400 trials per year, beginning every year in 2023. We've had a pilot last year in the ground. This year, as I'll show you, we have 150 trials. We're going to update and enhance the MRTN. We did this last year. We'll continue to do this as new data come in. Develop the benchmarking tool by 2024 and the hindcasting and forecasting models shortly thereafter. Identify new systems to get into the model as well. And just wrap up here with a map of the state with the trials in 2022 this crop year scattered around the state. So we're looking forward to getting the results back from those and sharing those with the public and improving the recommendations for the state. And so with that, there's the next Iowa Learning Farms webinar, and I'd be happy to take any questions, Matt, that you may have gotten in the chat.
Yep, time for people to type in questions. The kind of first off, though, if you're on here for a DCA, CEU, email Liz Ripley. The email is there, ejukums@iastate.edu by today at 5 o'clock, including your name, the name you entered to watch the webinar, and your CCA number. And then Mike, if you can go to the next slide, and I'll kind of put out a announcement for the next webinar.
Yeah, there we go.
There we go. We have Chuck Burr from University of Nebraska-Lincoln is going to talk about using farm management competitions to improve efficiency and profitability. Okay, yep, still time for questions. I have a question though. So you talked about the forecast modeling that Soterius would be working on. Do you think that can help with making kind of individual year side dress decisions based on kind of the weather we've had up to that point?
Yeah, exactly, Matt. That's the goal of that forecasting tool, is really to help us side dress fertilizer recommendations. And also the benchmarking tool, I want to highlight how that couples with the forecasting tool by showing folks what the potential is for side dressing to increase the efficiency of an operation. But that forecasting tool will really highlight the uncertainty associated with those decisions and really hopefully help provide some confidence in those decisions as a result there. I also want to emphasize that while like the Iowa nutrient reduction strategy shows that nitrogen fertilizer is certainly not our biggest lever to pull, those wetlands are that I mentioned in terms of reducing nitrate loss to our waterways. In extreme years, I think there's great potential for the forecasting tool, kind of as I was getting to with those fall residual nitrate maps, to really improve applications and make some significant reductions and avoid some significant losses or under fertilization in extreme weather years.
I guess that, yeah, maybe one comment to amplify that point is I think it, that side dress decision could vary quite a bit throughout the state in a given year. I'm just thinking we have a site in Northwest Iowa that we've, Soterius helped make a recommendation for side dress at that site and recommended, because of being fairly dry to the end of June up there, recommended very little side dress nitrogen. Whereas if that had been run for Ames, might have projected a lot greater need because of the rainfall that we've gotten around here compared to Northwest Iowa.
Yeah, that's a great example. Yeah.
Okay, there's got a question that's come in here. Going back, if you can go back to that slide where you looked at the variability from the different factors. There you are. Yep, Mitch's slide, that one. On the slide that showed impact of various factors on variability, it appeared soil water was the smallest cause, but you later talked about the impact between poorly drained and well-drained soils. Can you elaborate on this, since this soil water showed little impact on variability?
Yeah, that's a great question. So the soil water factor here it's the soil water at planting, which it's just at planting. It's not integrated throughout the crop season. We could do that. That's a thing we want to do in the future, of course, and certainly that purple bar would get much wider in that case. Yeah.
had any specific questions that have come to you, Mike?
I'm trying to type them, but I haven't. I've got one finally typed here.
Great, I got it. Indicate that, assume that the tools and models that your group is producing could be applied to predict environmental outcomes, including N loss and drainage and N2O emission.
Yeah, absolutely. And so the reason why these tools can predict environmental losses is because essentially we have to predict environmental losses to predict the optimum nitrogen fertilizer rate. Predicting the optimum nitrogen fertilizer rate is an enormous challenge because there is so much nitrogen locked up in our soil organic matter, right? So if we have soil down to 4 feet, let's say, which the roots can go even deeper than that, we've clearly shown, there may be 10,000 pounds of nitrogen per acre in soil organic matter there. Microbes have been well shown to mineralize somewhere between 1 to 5% of that per year. So let's say 1 to 500 pounds per acre per year that they provide. On the high end, that's more than the crop needs. On the low end, it's not enough. And then, of course, there are environmental losses that take some of that away. And it's the balance of all those processes that essentially create the optimum nitrogen fertilizer rate for corn. And that's why these process models, the large scale data collection that we're making on farms, are so important for generating more specific fertilizer recommendations, because we really have to create these accurate mathematical representations of all these processes and all the factors that affect these processes, from soil moisture to temperature to the amount of residue, et cetera. It's, on and on, right?
Great, thanks, Mike. And there, I guess to amplify that, one audience member indicated that these types of tools are critical to reducing hot spots and hot moments of nutrient loss. The next question is, can you talk a little bit more about how manure might be incorporated in these new tools, and if any of the, the rate trials to date have manure, or might they in the future?
Yeah, that's a great question, and that's like really the first place we want to go as we think about things to bring into these models beyond more widespread practices. And we do have some manure trials this year, and the way we're integrating those into this initiative initially is we're using fields that have a base application of manure and then side dress on top of the manure with UAN, with urea ammonium nitrate. And that way, that does help us back out what the availability of that manure was, because we still do have some zero nitrogen treatments in those fields, and helps us to better understand what that uncertainty in the manure nitrogen availability is and how it affects the optimum nitrogen rates. That's definitely a place we're going in the future. I have a related question here in my chat as well, Matt, about variations in the use of nitrification and urease inhibitors, including those in future trials. And absolutely, these are all natural places to go. I think one of the really nice things about the scale at which we're working across the state too is that it allows us to tailor specific practices to the parts of the state where they're most common. So cover crops, for example, might be something we really focus on in Southeast Iowa. We may not have a whole lot of continuous corn trials down there. Urease and nitrification inhibitors, so nitrification inhibitors with fall ammonia, of course, would be something we would get in there immediately, right? Because that kind of is the standard there. But yeah, so we aim to get all these practices in as we work through this in time.
Kind of related to maybe something into the future, is your group also collecting any P data that might eventually lead to better guidance on P management?
Yeah, so we are not doing that at this time. So at this time, we're really trying to enroll fields where everything is optimized other than the nitrogen fertilizer rate. So we really want to target fields that have optimum pK, sulfur, fertility, and pH, essentially, where nitrogen and soil management, residue management, those are the factors that are being altered. That's where we are now. In the future, absolutely. I know some of the private companies that we're working with in partnership to get these trials on farms do these experiments with P. And so certainly they're thinking about it. The process models don't really have the P in them yet, but that is a place to go in the future.
And you mentioned a fair bit of soil sampling going on these sites. Are they taking, I guess, are they analyzing for soil test phosphorus as part of that?
We are not right now, but certainly that could be done. And if somebody was interested in that, we would be excited to talk to them about that.
Right, I don't have any additional questions on this side. Oh no! That when I say that, then they all start coming in. Could you speak to the types of management differences that are included in the ENOR on the current slide? On the management side, the management types of difference that are included on the ENOR on the current slide.
Oh yeah, sure. I can't offhand. Yeah. So I shouldn't say sure. I can't remember exactly what I'd have to ask Mitch what he was thinking about in terms of management there.
Yeah, and I can't either, Mike, because Mitch talked about this in his prelim or the committee meeting. All right, there is another one here. Are the analysis you are completing specific to Iowa? Could some of these recommendations apply in adjoining states, or would they need to complete their own similar data gathering and analysis?
I think they would want to do this on their own in their states. So certainly, if you're on the same physiographic region right across the border, the natural one to think about would be the Des Moines Lobe up in south central Minnesota. Yeah, I wouldn't hesitate to use a tool like this. But we are talking to other states that use the current MRTN system, Wisconsin in particular, to try and transfer our approach to other states, and we hope that they see this as a good way forward. Yeah. I have another one here, Matt. So can I describe the
Absolutely, that's great.
Yeah, the level of effort expected for farmers to account for all the factors that affect the optimum nitrogen rate. So how do you account for all these factors? So our goal is to get all these in these benchmarking tools, starting with the big ones first. So, we're going to go for the low-hanging fruit. That's why I brought up the residue and drainage management. These are two things that we know that the management of can consistently reduce not only in the amount, but the year-to-year variability in rates. So we're going to start with like relatively large levels like that, but then work towards other things like planting date and genetics, and move on from there. This is a lot of, I think, related to that question. I often get the question, well, how many years is this project? And the answer to that is, as long as the weather is different and farmers are innovating, this needs to be a continued project for the state's farmers and other stakeholders that depend on the outcomes of farms for their livelihood.
Did get another one here. It appears that accounting for residual N is low-hanging fruit. Is that correct?
Yeah, that is for sure. And so that is one of those soil tests that we're making on these experiments right now. Is we come in pre-plant and we're measuring the amount of residual soil nitrate left over in those fields, and we do think that is a very useful low-hanging fruit tool for farmers, especially those side dressing to make. Also, especially given the high nitrogen fertilizer prices now, I think it's a good idea.
One more here. Would you envision other tools that this project could lead to over time, like a planting date tool for corn?
Yeah, so there is a planting day tool for soybeans right now. If folks are interested in the planting date tool for corn, I'd encourage you to reach out to Soterios and the Iowa corn growers. Those would be the folks to contact about that. But ultimately, all those decisions have to go into a tool like this, because the planting date affects the nitrogen sink that we expect in that corn crop. And the bigger the nitrogen sink, the more nitrogen we need available for that crop. The timing of that also interacts with the organic matter mineralization, the environmental losses to impact those rates. So these are all important factors for sure.
Right, Mike, that's the questions I had. If there aren't any more, encourage folks to tune in next week. Chuck Burr from University of Nebraska-Lincoln. Mike, thank you very much for your presentation today and for the work on this really important topic. I'll give you the last word if there are any last comments.
Nope. Yeah, thanks, Matt. I appreciate the opportunity. And I guess the last word, I do have a last word. Anybody, again, I want to emphasize, anybody who farms and would like to participate in the trials or works with farmers and knows folks who would like to participate, don't hesitate to reach out to me. You can find my email on the internet pretty easily. Please get in touch. Thanks.
Thanks a lot, Mike.
Yep.